Today we're going to be looking at solving quadratic equations by completing the square. Our first example is y squared equals 32, and to undo that squaring we take the square root of both sides and we're left with y equaling positive and negative square root of 32. We know 32 is 16 times 2 and that the square root of 16 is 4, so we can bring that out and leave the 2 in the radical. So y ends up being plus or minus 4 times the square root of 2. Our second example is to solve 3x squared equaling 18. First thing we need to do is divide both sides of that equation by 3, and we find that x squared equals 6. Taking the square root of x squared, we get x, and on the right side we have positive and minus times the square root of 6. Our next example is x plus 5, the quantity squared, equals 20. Taking the square root of both sides, we find that x plus 5 equals plus or minus the square root of 20. But the square root of 20 can be broken down to 4 times 5, and we know the square root of 4 is 2, so we can bring that out and leave the 5 in the radical. So now we have x plus 5 equaling a plus or minus 2 times the radical 5. Subtracting 5 to both sides, we find that our x really is a negative 5 plus or minus the 2 times the square root of 5. Our next example is 3a plus 2, the quantity squared, equaling a negative 36. We take the square root of both sides and we find that 3a plus 2 equals plus or minus the square root of a negative 36. If we look at the square root of a negative 36, we know the square root of a negative 1 is I, and that the square root of 36 is 6. So we simply have 6i. Taking the 2 over to the other side by subtracting 2 to both sides of our equation, we're left with 3a equaling a negative 2 plus or minus 6i. We don't want 3a, we want to isolate that variable, so we divide both sides of the equation by 3, and we find that a equals a negative 2 plus or minus 6i, all divided by 3. Our next problem is to take x squared plus 6x equaling 7 to solve that by completing the square. Always look at that middle term, which in this case is 6x, and take the coefficient times 1/2, which 1/2 of 6 is 3, and then we square that. And so 3 squared is 9. So that's what we add to both sides of our equation. And we've left with x squared plus 6x plus 9 equaling 7 plus 9. The stuff on the left is now a perfect square, and it's x plus 3 quantity squared. And of course 7 plus 9 is 16. To undo that squaring, we're going to take the square root of both sides, and we find that x plus 3 equals plus or minus the square root of 16. We know the square root of 16 is 4, and we need to move that 3 over to the other side, so now we find that x equals a negative 3 plus or minus 4. Looking at the top route, we have a negative 3 plus 4, which allows x to be 1. Taking the bottom route, which is negative 3 minus 4, then x equals a negative 7. Our next example is to do another completing the square, and we're given x squared minus 3x minus 10. Well, the coefficient of the middle term is negative 3, so we take 1/2 times negative 3, and we find that to be negative 3/2. We take that amount and square it, and we find that that is 9/4. So that's the amount that we add to both sides of our equation, making the left side once again a perfect square. So now we have x minus 3/2, the quantity squared, equaling 49/4. Square rooting both sides of our equation, we find that x minus 3/2 equals a plus or minus square root of 49/4. But we know the square root of 49 is 7 and the square root of 4 is 2. So now we can write it by taking the 3/2 over to the other side as x equaling 3/2 plus or minus 7/2. Again, taking the top route, we have 3/2 plus 7/2 for a total of x equaling 10/2, which is 5. Taking the bottom route, we have 3/2 minus 7/2, which is a negative 4/2, or a negative 2. Our last problem is compound interest, and we're given the formula where A equals P times the quantity 1 plus R, all raised to the T power, where A is the amount and P is the principal, R is the rate, and T is time. And they give us this nice little example to find the interest rate if $4,000 is compounded annually and it grows to $4,161 in 2 years. So we simply take that formula and plug in what we know, and we have 4,161 equaling 4,000 times the quantity 1 plus R squared. Dividing both sides of the equation by 4,000, we find that 4,161 divided by 4,000 equals the quantity 1 plus R squared. We know when we divide 4,161 by 4,000, we find that that's 1.0404. Now taking the square root of both sides, the square root of 1.0404 is plus or minus 1.02, and taking the square root of the quantity 1 plus R squared is just 1 plus R. Subtracting the 1 to both sides, we end up with a negative 1 plus or minus 1.02 equaling approximately R. If we take the top route, we have a negative 1 plus 1.02, which just leaves us 0.02. Or if we do the bottom route, we have a negative 1 minus 1.02, which is a negative 2.02 for R. Well, the answer cannot be negative. We cannot have negative interest. So our answer must be this one, which is 0.02, or approximately 2%.